Number 1. The Clovis People. A continental toolkit meets a climate shock. Picture a hunter on a windswept plain near the close of the last ice age. In his hand is a stone weapon unlike anything that came before it on this continent. The point is long, leaf-shaped, and grooved down the center on both faces. That groove is called a flute, and it is the signature of an entire way of life. Archaeologists call this toolkit Clovis, named after the town in New Mexico where the first examples were identified in the 1930s. Clovis is not a kingdom, it is not an empire, it is not even a single ethnic group. It is a continental pattern of stone tool manufacture spread across what is now the United States, parts of Canada, and into Mexico, dated to roughly 13,200 to 12,800 calendar years before present. The Clovis fluting technique is a piece of prehistoric engineering. To make the flute, the napper struck a long, thin channel flake from the base of the point. That removed mass at the haft and created a recessed surface. The point could then be lashed onto a wooden spear or dart shaft with sinew and resin. Modern flint knappers who replicate the process describe it as one of the highest skill ceilings in stone tool work. A failed strike could shatter weeks of effort. These weapons were aimed at the largest animals the continent has ever known: mammoth, mastodon, Native American horse, giant ground sloth, camelops, the North American camel. Clovis kill sites preserve points lodged in rib cages and shoulder blades. Then, almost in archaeological lockstep, the toolkit vanishes. Right around 12,800 years ago, the climate flipped. Researchers call this the Younger Dryas, an abrupt return to glacial cold conditions after a period of post-ice age warming. In modern terms, imagine the planet midway through a recovery, then suddenly snapping back into a deep freeze for over 1,000 years. The learning curve behind Clovis is worth pausing on. Fluted points did not appear from nothing. Earlier projectile traditions in the Americas, including the contested pre-Clovis sites at Monteverde in Chile and the Gall site in Texas, suggest a long preceding history of stone tool experimentation. Clovis represents the moment when that experimentation produced a fluting standard so effective that it spread across a continent within centuries. In modern manufacturing terms, it was a successful production protocol scaled to the entire North American grasslands. What caused the climate shift is where the science gets contested. A team led by Richard Firestone proposed in 2007 that comet fragments or atmospheric airbursts struck the northern hemisphere, triggering the cooling and helping to wipe out the megafauna. Their evidence included magnetic grains, microspherules, soot, charcoal, nanodiamonds, fullerenes, and elevated platinum. Later platinum anomaly studies and sediment work at sites like Hall's Cave kept the debate alive, but many independent labs failed to replicate the most striking markers. The impact theory remains controversial. What is not controversial is that the classic Clovis pattern fades from the record soon after the boundary. Fluting disappears, toolkits become regional, hunters track smaller game. The people did not all die. The hunting strategy died. A continental food web collapsed faster than the culture built around it could adjust. The people survived in altered forms, but the world their tools were built for did not. Number 2. The Hopewell Mound Builders. A cosmic disaster hypothesis that collapsed under review. Now consider what happens when the disaster story itself becomes the subject of investigation. The Hopewell tradition flourished in the Ohio River Valley between roughly 200 BCE and 500 CE. It was not a kingdom. It was a ceremonial and exchange network linking communities along the Scioto, Great Miami, Little Miami, and Ohio rivers. The Hopewell built earthworks of staggering geometric precision. Circles, squares, and octagons covered tens of acres. Some alignments tracked the 18.6-year lunar cycle. The Newark earthworks in central Ohio cover roughly 4.5 square miles. The octagon there is precisely aligned to the maximum northern moonrise. Their long-distance trade brought mica from the Appalachians, copper from the Great Lakes, obsidian from Yellowstone, marine shell from the Gulf of Mexico, and meteoric iron from sources still being mapped. The logistics of moving obsidian from Wyoming to Ohio, by foot and by canoe, suggest organized exchange networks operating across distances comparable to a modern coast-to-coast supply chain. In 2022, a team led by Kenneth Tankersley published a paper in Scientific Reports proposing that a cosmic airburst between 252 and 383 CE devastated the Hopewell heartland. An airburst, in modern terms, is what happened over Tunguska, Siberia in 1908. A space rock explodes in the atmosphere before reaching the ground. Heat, pressure waves, and a rain of melted particles spread across hundreds of square kilometers. No crater required. The Tankersley team reported finding micrometeorites, iron and silicon microspherules, and iridium and platinum anomalies across 11 Hopewell sites. They described a charcoal-rich, fire-hardened layer they interpreted as evidence of widespread burning. The story attracted enormous press coverage. Then it collapsed. The paper was retracted. A 2023 response argued that the data did not establish synchronous burning, did not require an extraterrestrial source, and did not pass basic stratigraphic tests. Burn layers, the critics noted, can come from ritual fires, from domestic hearths, from wildfire, or from controlled site cleaning. The radiocarbon dates spanned more than a century. That is not a single event. That is a window. The actual decline of Hopewell ceremonialism is better described as a slow reorganization. Mound construction tapered off after about 500 CE. Long-distance exchange networks fragmented, settlement patterns shifted, the people did not vanish. The ritual system that built earthworks fell out of use. Here, the most important collapse may not have been a civilization, but a hypothesis. Number 3. Cahokia. The first city north of Mexico and the river that changed sides. Move now to the Mississippi floodplain near present-day St. Louis. Around 1050 CE, something archaeologists call the Cahokian Big Bang transformed a modest village into the largest pre-contact city north of Mexico. Population estimates at peak range from 10,000 to 20,000 people. The central feature, Monk's Mound, is the largest earthen pyramid in North America. It rises about 100 feet, covers roughly 14 acres at its base, and was built in stages from compacted earth carried in baskets, basket by basket, by tens of thousands of laborers across decades. Surrounding Monk's Mound was the Grand Plaza, a leveled ceremonial space larger than 35 football fields. Beyond that lay neighborhoods, ridgetop burial mounds, ritual precincts, and a defensive palisade. By modern engineering standards, the leveling of the plaza alone represents an immense earth-moving project carried out without metal tools, draft animals, or wheeled vehicles. The estimated total volume of earth moved at Cahokia, across all mounds and platforms, exceeds 22 million cubic feet. The woodhenge, a circle of red cedar posts set west of Monk's Mound, served as a solar calendar. Archaeologists have identified at least 5 successive woodhenge constructions, each rebuilt as posts decayed or as ritual requirements changed. The early growth correlates with favorable climate. Sediment cores, collected by Sam Munoz from Horseshoe Lake and Grassy Lake, show wetter conditions during Cahokia's rise. That moisture supported maize agriculture intensification. Cahokians ate maize, squash, chenopod, maygrass, sumpweed, deer, fish, waterfowl, and floodplain plants. The Richland Complex and upland farming zone supplied the city with surplus grain. Then the system began to fail. By around 1150 CE, the Richland Complex was largely abandoned. The construction of a defensive palisade requiring an estimated 20,000 logs suggests rising social tension or external threat. By around 1200 CE, population may have dropped by half. By 1350 CE, Cahokia and much of the central Mississippi Valley were depopulated. The cause was not a single catastrophe. Tree ring records show drought sequences. Lake cores reveal increased Mississippi River flooding in the same window. Munoz's flood deposits document major overbank events that would have inundated low-lying neighborhoods. A city built on the productivity of a floodplain became trapped between drought-reducing harvests and floods damaging fields. The palisade went up, came down, went up again. Cahokia's power came from water, and its crisis came from water too. Number 4. The Mississippian Polities, the second collapse after Cahokia. After Cahokia faded, the cultural pattern it helped spread continued for another 2 centuries across the southeast. Archaeologists call this world Mississippian, and it ran roughly from 1200 to 1600 CE. The major centers included Moundville in Alabama, Etowah in Georgia, Spiro in Oklahoma, Kincaid in Illinois, and the Middle Cumberland towns of Tennessee. These were ranked chiefdoms led by paramount chiefs whose authority rested on tribute, ritual, ceremonial, feasting, and control of stored maize, beans, and squash. The food base looks similar across the region: maize as a staple, beans for protein and nitrogen fixation, squash for storage. hickory nuts, fish from oxbow lakes, deer and turkey from managed forest edges. The political ceiling was always the same. A bad year emptied the granaries. 2 bad years in a row threatened the chief's legitimacy. After about 1300 CE, the climate turned against them. The Little Ice Age brought cooler summers and more variable rainfall. Unlike the Hohokam in Arizona, who built permanent canals, Mississippian farmers depended almost entirely on rainfall. Their fields had no irrigation insurance. Tim Pocketat's syntheses of Mississippian archaeology, alongside lake records showing reduced summer rainfall, point to repeated drought as a structural stressor. The result was uneven, but cumulative. Moundville shifted from political capital toward mortuary and ceremonial use, its population dispersing into smaller surrounding communities. Etowah experienced cycles of violent reorganization, with evidence of burned structures and defensive earthworks. Spiro's ceremonial fluorescence, marked by the famous engraved shell gorgets and copper plates from the Craig Mound, lasted until about 1450 CE before sharp transformation. Across the lower Ohio and central Mississippi, archaeologists identify a pattern called the vacant quarter, a regional depopulation visible in the absence of late Mississippian sites where earlier ones flourished. European contact later brought disease, slave raiding, and disruption that accelerated change, but the political fragmentation began before Hernando de Soto's expedition arrived in 1539. The mounds remained, but the authority that made them meaningful had fractured. Number 5, the Ancestral Puebloans, the Great Drought, and the empty cliff rooms. Travel to the Four Corners, the high desert junction where Colorado, Utah, Arizona, and New Mexico meet. The term Anasazi is now considered outdated and is replaced in current scholarship by Ancestral Puebloans, the term preferred by descendant communities. From roughly 700 CE through the late 1200s, these dryland farmers built one of the most architecturally sophisticated traditions in North America. Chaco Canyon, in northwestern New Mexico, contains great houses with walls 4 stories tall, doorways aligned to solar and lunar events, and an engineered network of roads radiating into the desert for miles. Pueblo Bonito alone has more than 600 rooms. Mesa Verde, in southwestern Colorado, contains cliff dwellings tucked into sandstone alcoves, including the 150-room Cliff Palace. The Kayenta region in northern Arizona produced its own cliff and mesa-top settlements. The architecture demanded thousands of timber beams hauled from forests dozens of miles away. Recent strontium isotope studies of beams at Chaco have traced individual timbers to specific mountain ranges, including the Chusca Range to the west and the San Mateo Mountains to the south. Some beams were carried more than 50 miles by hand, without wheeled transport. The dating of these sites is precise because of dendrochronology. Andrew Ellicott Douglas, an astronomer working in Arizona in the early 20th century, established that tree rings record annual growth and that overlapping samples could build a continuous calendar. Beams from great houses can now be dated to the exact year they were cut. That same method also reconstructs rainfall. 2 droughts dominate the record. The first, from roughly 1130 to 1180 CE, weakened Chaco. The second, from 1276 to 1299 CE, is known simply as the Great Drought. 23 years of below-average precipitation devastated dryland maize, reservoirs dried, soils thinned. Some sites show evidence of violence during the worst years. Christy Turner's interpretation of the Cowboy Wash assemblage as evidence of cannibalism remains contested and culturally sensitive, and most archaeologists treat it cautiously. Violence existed. Its scale and meaning are debated. By around 1300 CE, many of the great northern sites were sealed and abandoned. The people did not vanish. They moved south and east. Their descendants live today at Hopi, Zuni, Acoma, and the Rio Grande Pueblos. They did not vanish into the desert. They moved with what the drought allowed them to carry. Number 6. The Hohokam. The irrigation civilization that turned water into a trap. In the Sonoran Desert of southern Arizona, the Hohokam tradition developed an entirely different solution to aridity. From roughly 300 or 450 CE through 1450 CE, they engineered the largest prehistoric irrigation network in North America. The Phoenix Basin, watered by the Salt and Gila rivers, became a continuous agricultural landscape stitched together by hand-dug canals. The scale is hard to overstate. A single canal at Pueblo Grande measured over 2 meters deep, 10 meters wide, and roughly 7 miles long. A second canal in the same network reached around 15 miles. Together, the Pueblo Grande system may have irrigated about 20,000 acres. The canals were dug with stone tools, digging sticks, and woven baskets. The labor was coordinated across multiple villages. The total length of Hohokam canals across the Phoenix Basin, when mapped together, exceeds 500 miles, making it the largest prehistoric irrigation network in North America. Patricia Crown and Jerry Howard's irrigation studies established that maintenance of these systems required constant cooperation between communities upstream and downstream. A breach in an upstream headgate could drop water levels across dozens of villages downstream within hours. The Hohokam built platform mounds, ball courts borrowed from Mesoamerican traditions, walled compounds, and dense cemeteries. Snaketown, occupied for over 1,000 years, contains hundreds of pit houses and one of the longest continuous archaeological records in the Southwest. They were not passive desert survivors. They were hydraulic engineers operating at a scale that, in modern terms, would require permits, surveying crews, and a public works budget. Their downfall illustrates a chemical principle. Salt river water carries dissolved salts. In arid climates, irrigation water evaporates from the field surface, leaving those salts behind. Over generations, sodium accumulates in the soil. It damages clay structure, reduces drainage, and lowers crop productivity. This is salinization, and it is a problem facing modern arid agriculture from the Imperial Valley to Central Asia. The Hohokam also faced flood damage. Pueblo Grande records show major Salt River floods in 1358 and again from 1380 to 1382. Floods can leach salts from soil, which sounds beneficial, but they also tear out canal headgates, breach earthen berms, and bury fields in coarse sediment. By 1450 CE, the great irrigation system had fragmented. Descendants survive today as the O'odham and Peeposh. The Hohokam mastered water, but water obeyed chemistry before it obeyed civilization. Number 7. The Fremont Culture. Granaries, waiting for harvests that stopped coming. North and west of the Ancestral Puebloans in Utah, eastern Nevada, western Colorado, and parts of the northern Colorado Plateau lived a different kind of farming people. Archaeologists call them the Fremont. The name describes a pattern, not a nation. Fremont sites share certain markers: gray pottery with distinctive temper, one-rod and bundle basketry, moccasins made from the dew claws of large mammals, and clay figurines with elaborate hair ornaments. The Fremont peaked in the 11th and 12th centuries CE under more favorable climate conditions. Their economy blended archaic foraging traditions with Puebloan-style farming. They grew corn, beans, and squash in pockets of arable soil. Where conditions allowed, they used water diversion to extend planting. They lived in pit houses and small surface villages, and they built granaries tucked into cliff alcoves to protect stored grain from rodents and rivals. Stephen Sims's research on Fremont and Great Basin archaeology emphasizes the flexibility of this lifeway. People could shift between farming and foraging as conditions demanded. That flexibility had limits. Drought sequences in the western interior between 990 and 1060 CE, again from 1135 to 1170 CE, and finally from 1276 to 1297. CE pressed Fremont farming toward its ecological edge. Shorter growing seasons reduced maize yields. In some regions, winter precipitation increased while summer rainfall declined, meaning moisture arrived when crops could not use it. By around 1200 to 1300 CE, the Fremont pattern becomes difficult to identify archaeologically. The pottery types disappear. The granaries stop being restocked. Settlements scatter. Some scholars argue that the expansion of Numic-speaking peoples, ancestors of today's Ute, Paiute, and Shoshone, displaced or absorbed surviving Fremont communities. A note of caution is needed about Barrier Canyon-style rock art in the same region. Some of the most famous figures predate the classic Fremont period and should not be lumped into Fremont culture without care. The Fremont left no fallen capital. They left storage architecture in landscapes that stopped feeding them. Number 8. The Patayan, the river that kept rewriting the map. Along the lower Colorado River, the lower Gili, and across western Arizona and southeastern California, the Patayan tradition flourished from roughly 700 to 1500 CE. Archaeologists divide them into three phases. Patayan 1 ran from 700 to 1050 CE. Patayan 2 ran from 1050 to 1500 CE. Patayan 3 ran from 1500 to 1900 CE. Within those phases, scholars further distinguish lowland Patayan, the floodplain farmers, from upland Patayan, more mobile groups in the surrounding deserts. Their farming method was unlike either the Hohokam or the Ancestral Puebloans. They practiced floodwater agriculture. Rather than building permanent canals, they planted in the wake of seasonal floods using the moisture and silt that the receding river deposited. It was a productive system in good years. It also tied their communities directly to a single river that refused to stay still. The Colorado is one of the most geomorphologically active rivers in North America. Its meanders shift. Its channels avulse, meaning the entire river abruptly jumps to a new course. Cut off strand old oxbows, floodplains rework themselves. A village that sat beside the river in one generation could find itself stranded miles from water in the next. Jerry Schaefer and Joseph Ezzo's work on Lower Colorado archaeology documents this continually shifting landscape. Archaeologists track Patayan presence largely through Lower Colorado buff ware, a distinctive pottery that survived where settlements did not. The Patayan also produced the Blythe intaglios, a set of monumental geoglyphs carved into the desert pavement near the Colorado River. The largest human figure measures about 171 feet long. The technique was simple in principle. Workers scraped away the dark, oxidized surface stones to expose lighter soil beneath. They created 6 major figures and many smaller ones. These geoglyphs remain sacred to the Mojave and Quechan peoples, whose creation traditions reference the figures. Most Patayan sites near the river have been buried, eroded, or destroyed by channel migration. The lack of monumental architecture on the scale of mounds or great houses makes their history especially hard to reconstruct. They did not vanish. Their descendants are the historic river Yuman peoples. For the Patayan, disaster was not one flood. It was a river that would not hold still. Number 9. The Dorset Culture, when the Arctic warmed enough for a new world to enter. Far to the north, across the eastern Canadian Arctic, Greenland, and into Labrador and Newfoundland, lived the Dorset. They are sometimes called Paleo-Eskimo, a label distinguishing them from the later Thule and modern Inuit. Their tradition spans roughly 500 BCE to 1500 CE, broken into early, middle, and late Dorset phases that vary by region. Dorset technology was tightly adapted to a cold, ice-rich Arctic. They hunted seals at breathing holes and ice edges, took walrus from haul-out sites, and harvested marine mammals along open water leads. Their toolkit included carved harpoons, snow knives for cutting blocks of building snow, soapstone vessels for rendering oil, and a remarkable artistic tradition. Dorset carvings in ivory and antler depict humans, bears, and animal spirits with striking economy of line. Robert McGee's Arctic archaeology positioned Dorset as a culturally distinct tradition rather than an early form of Inuit. What Dorset apparently lacked is as important as what they had. The archaeological record provides little evidence of dog sleds, large open boats called umiaks, the kayak in its later form, the recurve bow, or the systematic whaling gear that defined the Thule. In an environment where mobility and access to large prey are everything, those gaps mattered. Beginning around the year 1000 CE, the medieval warm period altered Arctic conditions. Sea ice patterns changed, whale migration routes shifted, routes opened that had been closed for centuries. Around the same time, the Thule, ancestors of modern Inuit, began expanding eastward from the Bering Strait region. They arrived equipped with dog traction, large boats, bows, and bowhead whaling technology. Within a few centuries, the Dorset disappear from the archaeological record. Ancient DNA work by Manasa Raghavan and colleagues published in 2014 established that the Paleo-Eskimo population represented by Dorset shared little genetic continuity with modern Inuit. This is one of the strongest cases in the Americas of population replacement rather than cultural transformation. The mechanisms remain debated. Competition for prey, starvation in marginal seasons, possible disease exchange, and direct conflict have all been proposed. Dorset objects appear in Thule sites, but those could reflect trade, scavenging, or borrowing rather than peaceful coexistence. The Arctic opened, and when it did, an older world had nowhere colder to retreat. Number 10. The Channel Islands people. the coastline that sank beneath the Pacific. Off the coast of Southern California, the northern Channel Islands today consist of San Miguel, Santa Rosa, Santa Cruz, and Anacapa. During the last ice age, these 4 islands were a single landmass that geologists call Santa Rosae. Lower sea levels exposed a continuous island roughly 76 miles long. On Santa Rosa Island, archaeologists have recovered the remains of Arlington Springs Man dated to about 13,000 calendar years ago. He is among the oldest human remains in the Americas. The people who reached Santa Rosae were maritime. They needed watercraft to cross the Santa Barbara Channel, even at its narrowest ice age extent. Their economy fits a model that John Erlandson and colleagues call the Kelp Highway. Coastlines along the Pacific rim of the Ice Age were lined with kelp forests, productive zones full of shellfish, fish, sea mammals, seabirds, and edible seaweed. A maritime people moving along this corridor would have found a continuous food landscape stretching from Asia to South America. Then the world changed. Beginning around 18,000 years ago, post-glacial sea level rise accelerated. Ice sheets melted. Oceans rose by more than 400 feet. The flat coastal shelves where Ice Age peoples camped, fished, and buried their dead were submerged. Most paleo shorelines older than about 7,000 years now lie underwater. By around 10,000 years ago, Santa Rosa had broken into the 4 separate islands we see today. The archaeology of the drowned coast is extraordinarily difficult. Wave action, sediment burial, and tectonic activity distort or destroy submerged sites. Erlandson's team has used GIS modeling to identify drowned landforms with high probability of preserving archaeological material. Some sites have been recovered. Most are likely lost. The pygmy mammoths of Santa Rosa Island, a dwarf species that evolved in island isolation during the late Ice Age, hint at how distinct the ecological setting once was. The descendants of these earliest islanders are the Chumash, an island Chumash, whose maritime traditions and plank canoe technology continue to be documented. Their world did not burn or collapse. It sank one tide line at a time. Now step back from the case studies and look at the patterns. Across these 10 traditions, the disasters fall into recognizable categories, and the evidence behind each category varies in strength. The next 4 sections examine those categories. The most cinematic explanations for prehistoric collapse involve impacts and airbursts. Comets, asteroids, atmospheric explosions, and volcanic eruptions all have documented effects on climate and ecosystems. The mainstream view is that abrupt climate shifts can occur without impacts, driven by ocean circulation changes, ice sheet meltwater pulses, volcanic forcing, or atmospheric feedback loops. The archaeological view is that cultural change usually follows environmental stress, but rarely requires a single explosive cause. A fringe and speculative view, advanced by a small group of researchers, holds that several ancient collapses may have been triggered by a recurring stream of comet fragments striking the inner solar system. The technical concepts matter here. An airburst is an atmospheric explosion that deposits energy without leaving a crater. The 1908 Tunguska event flattened roughly 2,000 square kilometers of Siberian forest without producing one. The lack of a crater, therefore, does not automatically disprove airburst scenarios, but it raises the bar for evidence. Microspherules, the small glassy beads cited in both the Younger Dryas and Hopewell hypotheses, can form from impacts. They can also form from volcanic eruptions, industrial contamination, or intense wildfires. Nanodiamonds and platinum spikes can occur from extraterrestrial sources, but they require careful stratigraphic control to rule out mundane causes. For a regional catastrophe to be demonstrated, the boundary layer must be the same age across multiple sites. Radiocarbon ranges that span decades or even centuries weaken single event claims. Burn layers can reflect ritual fires, domestic hearths, wildfires, warfare, or routine site cleaning. The Younger Dryas impact hypothesis remains debated because some markers are reported by some teams and fail to replicate in others. The Hopewell airburst paper was retracted, illustrating the same standard from a different direction. A documentary can explore the possibility of sky disasters honestly while clearly stating that such claims are not proven. Modern relevance is direct. Planetary defense programs like NASA's DART mission demonstrate that asteroid threats are taken seriously today. The science of detecting, deflecting, and recording impacts is advancing. The sky may have mattered in deep prehistory. The ground decides what can be proven. Across the case studies, water instability is one of the strongest recurring explanations. Cahokia, the Hohokam, the Patayan, and the Channel Islands. Peoples all faced disasters mediated by water, but the form differed in each case. Mainstream archaeology treats water as the dominant variable in many North American collapses. Speculative views suggest that submerged coastal worlds may hide much older migration evidence than currently acknowledged. Several technical concepts unify these cases. Floodplain fertility comes from the deposition of nutrient-rich silt during overbank events. The same floods that build soil also destroy houses, fields, and cemeteries. Avulsion is the abrupt rerouting of a river to a new channel, a process that can strand entire settlements within a season. Salinization is the accumulation of dissolved salts in irrigated soil as evaporation concentrates them at the root zone. Cahokia's lake cores, analyzed by Sam Munoz, document Mississippi River flooding contemporary with the city's decline. Hohokam records show major salt river floods in 1358 and from 1380 to 1382, damaging the canal network. Patayan settlements were repeatedly erased by Colorado River channel migration. Channel Islands' paleo shorelines were drowned by post-glacial sea level rise that submerged the world inhabited by Arlington Springs man. The agricultural lesson is that water control creates surplus, but it also locks people into infrastructure. A canal must be maintained. A floodplain settlement must be ready to rebuild. The preservation lesson is that floods both create archaeological deposits and destroy them. The geographic lesson is that early coastal migration routes may now be under modern oceans, hidden from standard land-based survey methods. In modern terms, the parallels are immediate. Levees protect cities until they fail. Reservoirs store water until drought lowers them below intake levels. Soil salinity is a measurable problem in the Imperial Valley today. Coastal retreat is reshaping policy from Louisiana to Bangladesh. The same force that fed these worlds could erase their foundations. Climate does not need to destroy buildings to destroy civilizations. It only needs to reduce food reliability long enough for social systems to fail. Mainstream archaeology identifies drought and cooling as among the strongest explanations for ancestral Puebloan, Fremont, Mississippian, and Cahokian instability. Climate stress turns dangerous when combined with population density, social hierarchy, conflict over remaining resources, and storage limits. Some prehistoric droughts may even survive in oral traditions as mythic abandonments that scholars can now correlate with paleoclimate records. Megadrought is the term for a long, severe drought lasting decades rather than seasons. The methods for detecting megadroughts are well established. Tree ring reconstruction reads annual growth bands to identify poor years. Lake cores preserve sediment chemistry, pollen, charcoal, and flood layers that together reconstruct centuries of climate. Maize, a tropical grass adapted to summer rainfall, is highly vulnerable to growing season drought. A maize-dependent society cannot easily switch to wild foods at scale. The Great Drought of 1276 to 1299 CE is the most precisely dated megadrought in the American Southwest, anchored by Andrew Ellicott Douglas's tree ring chronology and refined by every subsequent generation of dendrochronologists. The Fremont faced repeated drought intervals that undercut their marginal farming. Mississippian chiefdoms experienced Little Ice Age, cooling that reduced summer rainfall and stressed maize harvests. Cahokia rose during a wet period and declined as drought and flood instability returned. The food system lesson is direct. Stored grain delays collapse but cannot solve repeated harvest failure. The political lesson is that ritual and chiefly authority loses legitimacy when promised abundance fails to arrive. The settlement lesson is that people cluster near remaining water sources, intensifying conflict. The migration lesson is that abandonment is often a rational adaptation, not a failure. The modern parallels include climate migration, drought-driven crop insurance markets, monoculture vulnerability, and reservoir-dependent cities. A civilization can survive one bad harvest. It may not survive a generation of them. The word erase does dramatic work, but it does not always describe what actually happened. Most of these peoples were not literally wiped out. Their visible archaeological patterns changed, dispersed, merged, or moved. Mainstream archaeology defines collapse as institutional breakdown, settlement abandonment, or material culture change. People often survive collapse by migrating, joining neighbors, changing subsistence, or abandoning old symbols while keeping older identities. The technical distinction is between material culture and identity. Material culture includes tools, pottery, architecture, burial practices, and settlement layouts. These leave physical traces. Identity, language, and oral tradition do not preserve in the same way. Archaeologists can see that a pottery type ended. They cannot always see whether the people who made it died, moved, or changed what they made. Across the case studies, continuity is the rule rather than the exception. Post-Clovis peoples continued with regional adaptations. Pueblo communities at Hopi, Zuni, Acoma, and the Rio Grande Pueblos descend directly from ancestral Puebloans. The Tohono O'odham and Acamel O'odham, along with the Piposh, descend from Hohokam ancestors. Patayan groups transformed into the historic River Yuman peoples. Chumash and Island Chumash communities maintain maritime traditions that link directly to the Channel Islands past. Mississippian Polities collapsed politically, but native societies across the southeast continued into the contact era and beyond. The Dorset case is the strongest exception. Ancient DNA suggests genuine population discontinuity between Dorset and the Thule who replaced them. Even there, the mechanisms remain uncertain. Hopewell, ritual decline did not equal a dead population. Many ceremonial systems end while the people who once sustained them continue under new arrangements. Ethical writing about these histories requires separating mystery from misinformation. Speculation is legitimate when labeled. Fabrication is not. Descendant communities exist, hold knowledge, and have legal and cultural standing that academic researchers and documentary makers must acknowledge. What disappears in archaeology is often a pattern, not a people. These 10 traditions represent some of the most innovative responses to environmental challenge in the human record. The Clovis fluting technique pushed lithic engineering to its skill ceiling. Hopewell, earthworks tracked astronomical cycles with precision. Cahokia leveled a ceremonial plaza larger than 35 football fields without metal tools. Mississippian chiefdoms managed surplus across thousands of square miles. Ancestral Puebloans built 4-story masonry in the desert and aligned doorways to lunar standstills. The Hohokam moved water across the Phoenix Basin through canals stretching dozens of miles. The Fremont blended foraging and farming on the edge of viability. The Patayan farmed in partnership with one of the most volatile rivers on the continent. The Dorset survived in conditions that would defeat most modern equipment. The Channel Islands, peoples crossed open water at the end of the Ice Age and built an island maritime tradition that endures. Collapse, where it occurred, was usually multi-causal. Climate, infrastructure, food systems, politics, conflict, and migration interacted. 3 concepts help organize the picture. Resilience is the ability of a system to absorb shocks without losing its identity or function. Thresholds are points where gradual stress produces sudden reorganization. Feedback loops are chains of cause and effect where one failure worsens the next. Drought weakens crops. Weak crops weaken political authority. Weak authority worsens conflict. A 4th concept, path dependency, explains why societies that invested in canals, mounds, maize, or coastal roads found alternatives harder to access once their environments shifted. The lessons from the case studies resist easy summary, but specific patterns recur. A toolkit built for one ecological world may fail when that world changes. Evidence must be strong enough to survive reanalysis, and dramatic claims sometimes do not. Urbanism depends on water systems that can turn unstable. Political authority tied to surplus can fracture when harvests fail. Migration can be the most intelligent response to permanent drought. Engineering success can create long-term chemical vulnerability. Flexible societies may fade archaeologically because they successfully adapt. Mobile rivers erase both farms and evidence. Climate change can open routes for better-equipped competitors. Sea level rise can hide the oldest chapters of human history beneath the modern shoreline. In modern terms, these are the same forces that planners, engineers, climate scientists, and archaeologists confront today. Floodplain cities, salinizing irrigation, drought-driven migration, coastal retreat. Submerged paleo landscapes that may yet reveal more of the human past as marine archaeology develops. These civilizations innovated using the fundamental laws of nature. Water flow, soil chemistry, seasonal growth, animal migration, ice, fire, stone. They were not primitive victims of environment, they were skilled adapters whose systems eventually met physical limits that shifted faster than their institutions could absorb. Their ruins are not warnings that people failed. They are warnings that even brilliant systems have physical limits, and that the next chapter of human adaptation will be written with the same fundamental constraints in mind.